So the first part of this section is not bad at all. Okay, we're going to look at operations with functions, and what that's going to look like is something like this. Okay, so if you want to take a picture of this screen, you may. We'll talk about what this means that we're doing, and then we'll go through it. Now, in this first part of the section, in your homework, it's going to say find the sum of the functions, which is what this is, the difference, and then multiplying the functions together. It's also going to ask you to divide, and we're not doing the division. Okay, so when you get to your homework, the reason I'm not showing you the division is because we're not doing it. Okay, so simply all this means is take function f and function g and add them together. Okay, the second one means subtract g from f, and this one means multiply. Okay, so here's what it's going to kind of look like. Here's what it really boils down to. Okay, add them, subtract them, multiply them. So go ahead and do those, simplify those out, and show you what your final answers will be. First one, since there was nothing being multiplied by either one of these, you could really just drop the parentheses. Okay, so you should have gotten x squared plus 8x minus 4. Raise your hand if you got that. Very good. The only issue we had for number 2 is that we have to distribute. So it's minus 3x, then it turns to plus 2. Okay, so you should have gotten x squared plus 2x. So this would be 5x minus 3x is 2x, and then minus 2 plus 2 is just 0. How many had that? Good. All right, so on this last one, you had to distribute. Okay, and how you distribute is kind of up to you. You've got 3 things times 2 things. Okay. And this is what your final answer should have been after you combine like terms. 3x to the third plus 13x squared minus 16x plus 4. This is all review stuff. It's just a different notation, a different form, different format of doing things that you've already done with polynomials. Okay, how many had all 3 of those right? Okay, good. So that's the first part of your lesson. It's going to be pretty straightforward. Like I said, the directions are going to ask you to also do division. It's going to look like this. Do not do it. We are not doing this. Okay? So don't worry about that. Okay, the next part of our lesson is a little trickier. Okay, and this has to do with composite functions. And before I actually get into a composite function, what I want to do is show you an example of something that you're familiar with. Okay, if I gave you a function like this, yep, and I said find f of 2. Okay, do that real quick. All right, this is pretty straightforward. You plug 2 in for everywhere that you see an x. So that equals 4 plus 8 minus 2, which is 10. Right? How many got that? Okay, this is pretty straightforward. You know how to do this. You've proven you know how to do this. What's going to happen with composite functions is instead of having just a constant that we're going to substitute in, we're going to substitute an entire other function in. Okay, and so we got some notation things and some other definitions. So a composite function is made by using one function as the input value for the other function. So in the example that I just gave you, 2 was the input value. Okay, and we inserted that, inputted that into the function f. For composite functions, we're going to take a separate function and it will become the input value. Okay, there's some notation things that we're going to look at, and then this is going to play a part today, but we're going to actually use it later on. So here's some notation things. Okay. So this open circle like this, as opposed to on the previous slide where we had the multiplication, that means f of g. Okay, and some of the memes on the wall have to do with this, f of g. Okay, sometimes it's written like this. Sometimes it'll be written with just a bunch of parentheses like this. Okay, so these three things all equal the same thing. Okay. What it's really saying in all three cases is that g of x is the input value. It's going to be in place of where that 2 was on the example that we just did. G of x is the input value. Okay. And the order, when you write it with the open circle, matters. That means g is the input value into f. And I believe that's what the next back real quick. Says yes. Bless you. Okay. So g of x is the input value. So everywhere in f where there's an x, you're going to take the value of g of x and substitute it in. Just like we did with that little easy example that we started with. Everywhere there was an x, we took 2 and we replaced x with 2. In composite functions, everywhere there's an x in f, you're going to replace whatever those x's are with g of x. Okay? Now, we can also look at it the other way. We can insert f into g. And when that happens, the order of all of this will change. Okay? So here's what that would look like. Okay? The exact same thing with the order flipped. F is now the input value into g. The second one is the input value into g. This is all just the reverse order of this. Where f is now the input value. Over here, g was the input value. So here's the type of problems that we're going to look at. I put these up here for a reason. You can take a picture of this page if you want, or if you can write it down. But one of the things we are not going to do is state the domain and range for the composed function. So just know when you get to that in your homework, we're not doing that part. We're just doing f of g of x and g of f of x. For the first one, we're going to find f of g of x, which means g of x is the input value. Well, what does g of x actually equal? X minus 6. So x minus 6 becomes the input value. That whole thing gets inserted into f everywhere there's an x. Just like we did as if it was a number 2. Okay, we took 2 and we put it in place of every x. In this case, it's just not 2. It's going to be a different function. So here's where we start. Okay, first off, g is the input value, so I'm going to insert g into x in f. Right? So this is what we're talking about. Here's f of g of x. So this is x squared plus 2. Right? That's what f is. My input value is g of x. So instead of inserting 2 like I did in the original easy problem, we're inserting this entire other function. And as you already told me, g of x equals x minus 6. So in reality, what I'm doing is I'm just taking x minus 6, because that's g, and I'm plugging it into f everywhere there's an x. In this case, there's only one place. Okay? If there were multiple x's, like in my example, you'd plug it into every place there was an x. Alright, so like I have it here, that's really just x minus 6, because that's what g of x is, and now it's a matter of expanding that, multiplying it out, and seeing what you get. Now, I will tell you, some of you really botched this on the test, so hopefully you won't botch it now, but go ahead and simplify that out and see what you get. Some of you forget that really means x minus 6 times x minus 6. This does not equal x squared minus 36 or x squared plus 36, okay? There is a middle term. When you FOIL this out, there is a middle term, okay? So what you should get, x squared minus 12x plus 36, because you get minus 6x minus 6x, and then there's this plus 2, so I just combine 36 and 2, and that is my final answer. Okay? How many had that? Good. So again, the trick is understanding which function is the input value and which function is sort of the main function that you're inputting into. Okay? So in this case, because g came second, the x minus 6 is what is being inserted into f. And everywhere there's an x, we substitute that x minus 6 in, simplify it, and we're done. Okay? So of course we still need to find g of f of x, so we're going to flip it around now. Okay? When we flip it around, f becomes the input value into g. Why don't you go ahead and give that one a try and let's see how it goes. Okay, in this case, my input value is f. So all of this goes in for x. Again, if there was more than one x, you'd replace all the x's with it. Okay? So what we have here is x squared plus 2 minus 6. This is not being multiplied by anything, so I could really just drop those parentheses. And 2 minus 6 is negative 4. And that is my final answer. Okay, how many had that? So that one's easier, right? There was no squaring involved. There was just a regular old x. A lot of times there's going to be a number in front of here, so you're going to have to distribute. Or there's going to be more than one x. And that's really all 6-1 is. Now, take your time with the composite functions until you kind of get the hang of how to plug one into the other and do that repeatedly and cycling it back to do the other one. It takes a little while to get a hang of, and once you get the hang of it, though, you'll be in good shape. This by itself, like what we're going to do today, is really of no value. This is practice because we're going to use it in a specific way for 6-2. Okay, so we're going to apply everything that we're doing here in 6-2. Okay? Any questions?